All right, friends, if you haven't done so yet, make sure to grab your notebook and write these parent functions down. Sketch those out. You will absolutely need those. In the meantime, we are going to talk about the square root function and the cube root function. So when we go to graph a square root one, this is actually a little trickier because you don't want to just plug in anything for x and y. You'll notice on the previous ones that I have done -2, -1, 0, 1, and 2, but we can't put in a negative here. We just can't get anything out, right? It's not a real number. So the smallest number that we can have for x is going to be 0. And in order to, and if I do that, I would get 0. And then if I put in a 1, the square root of 1 is 1. Now, here's where it gets tricky. I don't want to get decimals or anything weird out. So the next perfect square that exists is 4. And in order for me to get a 2 here, I would have to put a 4 here. So if I do a 2 there, then if I put a 4 here, then I'm going to, oops, I swapped that around as soon as I said that. If I put a 4 here, then I get a 2 out here. So what do I have to put in for x to get, so my next whole number, you see I'm going on my output 0, 1, 2, and my next one's going to be 3. So for my y, I want a 3, which means for my x, I'm going to have to put a 9 in there, because if I get y equals the square root of 9, that means y equals 3. So when x is 9, y is 3. If we wanted to do 4, we would have to put in 16. And now I'm not going to graph that one because it's way off the chart, but I can graph these other ones. 0, 0, over 1, up 1, over 4, to 4, up 2, and then over 9. So that's 4, 5, 6, 7, 8, 9, and then up 3, just like that. And there is our square root function. So this is a neat one because you'll see that it only exists on like half of the graph. You can never have a negative under your square root. So as we talk about transforming these functions, you'll see how we can go about doing that. Okay, so now the cube root functions, the same idea here. You'll see that I haven't selected my -2, -1, 0, 1, and 2 for my x's, or for my x, because if I put those in, I'm going to get out a decimal, and I don't want to do that. So instead, I'm going to choose my y's. Now, it is a cube root function, which means that I can get negatives out. So I'm going to choose -8, -2, and then -1, 0, 1, and 2. Okay, now if I want a -2 for y, -2 equals the cube root of x. What do I have to put in for x in order to get a -2? That's going to be a -8. Now, if I want -1, the cube root, what do I have to put in for x to get a -1 is going to be -1. For 0, I just have to put in a 0. For 1, I put in 1. And then if I want to get a +2 out, the cube root of 8 will give me +2. It's a really good idea at this point to learn all your perfect squares, all your perfect cubes, and perfect squares especially up till 15, perfect cubes up till about 10, and even your perfect floors up to about 5 or 6, because that will be helpful identifying those friendly numbers. So let's talk about how this guy looks graphed. So if we go out -8, so 2, 4, 6, 8, and then down 2, that's right here, and then over -1, down 1, 0, 0, over 1, up 1, and then over 1, up 8, so that's 2, 4, 6, 8, and then up 2, just like that. So you'll see from a previous graph, when we did the one that looked like y equals x to the 3rd power, it looked very similar to this, but it was the other way, like that, right? So you can kind of start to see that those patterns exist, and by knowing your perfect cubes, it will make graphing these a lot easier. We'll see you next time.